Hi, welcome to Factorising Quadratics Next Level, the second lesson in an A-level topic on factorising quadratics, but there's going to be so much more going on. So that's just like one aspect of what I'm trying to just revise, actually. It's assumed that you've done a lot of this before. It's the sketching bit that's really I'm trying to push here. To start today, I'd like to try these two questions. So pause the video, give them a go. They relate to forming equations. So another kind of aspect of quadratics that we're revising. All right, I'm going to show you the answers to these. Hopefully you had a go, and then I'm going to go through them. So there we go. I'm doing this all without a calculator because it's an important skill to be able to do. Even if the A-level allows you to use a calculator, make sure your non-calculator methods are on point because there are questions that come up that you just can't get away with using a calculator, and also we're trying to improve at maths. We're not just trying to chuck things in the calculator and not understanding. I hope. So first one, we've given the area of a rectangle. We're given the sides in terms of x. So form an equation: base times height, x plus 5, x minus 1 equals 16. This is a quadratic equation. It just doesn't look like it at the moment. We need to expand the brackets. X squared minus x plus 5x, that's going to be plus 4x, minus 5 equals 16. Get it equal to 0. Standard practice for factorising. X squared plus 4x minus 21 equals 0. And we're back to solving quadratics just with an x squared, nothing like a 2x squared or anything. That's coming up. So it's going to be x and x. Factors of 21. Well, there's only 1 and 21, which isn't going to work, or 3 and 7, which is. It's going to be plus 7 and minus 3. That gives us x equals minus 7 or 3. Reject the minus 7 because it's a length of it's part of a length. Like you can see, you get negative lengths if you do that. So x is equal to 3. We're asked for the height and the width, so I've just got to then substitute that 3 back into here, which gives me 8 and 2. Of course, like maybe you could have guessed that at the start. You could have been like, oh yeah, some factors of 16, it's going to be 1 and 16 or 8 and 2. But like the point of this exercise is to be able to create a quadratic and solve it. There's harder questions that can be asked, so make sure you understand this method. If I change the area of the rectangle to 17, for example, you'd have to construct a quadratic, and then you'd have to use methods that we've not covered in A-level yet, although you may have covered them before. Second one, good old Pythagoras' theorem. We've got a right angle triangle, so we can write down A, so this is C, and let's call this A and B. We can switch those two around if we want. A squared plus B squared equals C squared, so we are again going to construct essentially a quadratic equation. It just doesn't look like it yet. So that is going to be true. Now we've got to multiply out double brackets. I'm just going to remind you what that means. I'm only going to do one of them in full. So x minus 6 squared is actually x minus 6 times x minus 6. Don't just be writing x squared plus 36. It's going to be x squared minus 6x minus another 6x, so minus 12x plus 36. Remember that. So it's going to be x squared minus 12x plus 36 plus x squared plus 2x, because I get an x from the one and an x from the other one, plus 1, and that's going to equal x squared plus 4x plus 4. I'm not going to get into any more detail on that. We can immediately just sort of cancel some terms out. Actually, there's an x squared on both sides, so let's just get rid of it. The others, I should probably just bring it together first. So I can write down x squared minus 10x plus 37 equals 4x plus 4. Okay, don't rush it. So x squared minus 14x plus 33 equals 0. And this isn't too bad to factorize because 33, yes, it's 1 times 33, but again, that's not going to work. 11 and 3, if I make it minus 11 and minus 3, that does indeed work. So I'm left with x equals 3 or 11. I've just written them in ascending order. Okay, we need to think about this. If I have 3, then I'd get a negative length again. I know x is positive, but I'd still get a negative length, so I've got to reject that one. 11 will work because I'll get 5, I'll get 13, and I'll get 12. 5, 12, 13, Pythagorean triple, right angle triangle with integer side lengths. So hopefully you're happy with that. That's the starter. That is linking into last lesson, but creating quadratics, and they're not always equal to 0. We're not doing any sketching here. We're just solving these quadratics. Okay, good work so far. Alrighty, the main thing today, the new thing, is now we're going to be looking at quadratics where we don't just have an x squared, we have a number in front of it. And I'm going to talk about 4 examples of dealing with that. And then I'll get you to try some. Of course, if you're feeling confident, you can pause the video, you can try them yourself. Absolutely, if I promote that. But then you look through, just check your answer, and then if it's if you've made any mistakes, try and understand why. And then I've set another, I think, 6 questions after that. So just making sure you can factorize things like this, but also sketch. We're not going to worry about finding the turning points or the line of symmetry for the quadratics. That's not the focus. I've talked through how you can do that. It just gets a bit messy, and there are other ways of doing it. I wanted to talk about it last lesson, but today let's just focus on finding where they intersect the axes. And also whether they're happy or sad quadratics, so we can immediately see that these two are both happy because they've got a positive 3 and a positive 2 there. This one looks like it's happier than that one, but they're both really happy. Right, we get the y-intercept for 3, so I'm going to write that down for both. Do you know what? No, I'm not. I'm just going to do one at a time. I don't want to do them all at the same time. Okay, so I've got the y-intercept. Now I'm trying to find the roots. Now remember, this is when it's equal to 0. So, but what am I going to do? I'm gonna do something first of all. I know I can set equal to 0, but I want to talk about this. Actually, this quadratic here, it's got a common factor of 2. So I can actually take 2 out and write it as 2 with a bracket x squared minus 6x minus 7. And that's really important actually, because now I've turned it into something that we've done last lesson. I can factorize this. It's going to be x minus 7 and x plus 1. And we get the roots x equals 7 or minus 1 from setting equal to 0. I've not actually at any point set it equal to 0, but I have essentially, I can just still jump straight to that. If you had set this equal to 0, you could have divided through by 2, but I shouldn't divide through by 2 here, technically. And that is all I need. I can now plot the key points and the quadratic. I'm not worried about the turning point. So I'm going to get minus 1. I'm going to get 7. It's going to go through minus 14. So let's just have it go down like this. And then I can see it's going to keep going down and it's going to come back up. So that point there, minus 17. I just want to say one thing. This will come in later on, but the fact that there's a 2 there actually has a bit of an impact. If I was just plotting this function by itself, it would actually look a bit like this. It would have exactly the same roots, but actually not quite like that. It would go through minus 7 for a start. That doesn't look like a 14. Sorry, that should have been a 14 here. It looks like I accidentally wrote minus 17. But back to if I was just sketching the bit in red, it would actually be less steep. It wouldn't go to infinity quite as quickly. It would look a bit like this. So just be careful when you have numbers in front. You can't just get rid of them. And you could potentially be asked to sketch both of these graphs on the same axes. And the one in red, just x squared minus 6x minus 7, it would be this one in red. and if I put a 2 by it, this. You'll do more on that, but I just wanted to say that. I decided not to get rid of the 2. They kind of look the same. They have the same roots, but they have different intercepts and different shapes. All right, I'm not going to stress too much about that. If you did divide by 2, you set it equal to 0 and divide by 2, you get away with it in this case. Right, so that is an example of having 2 in front of the x squared, but you can essentially you can deal with it by just factorizing out the common factor. Second one then, we get the y-intercept straight away. It's -6. This time, there's no common factor going into all of them. So I have to do a factorization with a 3x squared in it. And the only way that this will factorize is if I have a 3x here and an x here. Now, when you multiply out brackets, you multiply the numbers together to give the number by itself. So I need 2 numbers here to multiply to give -6. But they're not going to add to give -7 like they do on previous examples, like over here. Because now I've got to take into account that I'm timesing by 3x. So this is how I factorize these quadratics. You might, if you've got a different method that works, absolutely fine. But I'm going to show you how I do it. And if you like that method, if you haven't become confident with this yet, then you can use it if you like. So I just try some numbers basically, and normally I have a bit more space over here, but I don't have loads today. So I'm maybe going to try, maybe I try 3 and 2 because those multiply to give 6. I'll deal with the minus in a bit. When I multiply this bracket out, this is now a trial and error method. I do 3x times 2 to give me 6. Normally the space on the right, I'll do it really small. 6x and 3 times x gives me 3x. Now there's no way I can combine them to give me -7x. So essentially I don't use that. I need to try a different combination. So maybe I try 2 and 3. Now I do 3x times 3. Imagine that 3 is in the bracket. I'd get 9x. And I do 2 times x, I'd get 2x. This will work. I can combine these to make -7x if I make it -9x. And to make it -9x, I need to put a minus here. And I'm done. It's going to be 3x plus 2, x minus 3. If that one hadn't have worked, I would have had to try a different combination to get 6. It would have been 1 and 6 or 6 and 1. I got there on my second attempt, so we can stop at that point. That is how I factorize these quadratics. If you need more practice of this, because I'm only going to gloss over it today, then go and look back at a GCC lesson on this, factorizing quadratics where a is not equal to 1, a being the first coefficient in the quadratic. Because I'm going to be talking about it a little bit, but it's not going to be in lots of depth. So we're basically done because now we've got the roots. The roots are going to be when 3x plus 2 is 0, that's going to give me -2/3. I've essentially solved 3x plus 2 equals 0. So 3x plus 2 equals 0. I have -2 from both sides, 3x equals -2, and then I divide through by 3. We also get the root of 3 really quickly. That's all I need. I've got enough for this sketch. Okay, it's going to go through -6, so let's get that on there. And then -2/3. And 3. Put it over here. That will be enough. Let's draw the quadratic in. No, that's not a very good job. Try again. That's loads better. I can kind of see, because the root is closer to 0 there, I know it's going to kind of carry on and go down a little bit. If you had a turning point, then you'd know that for sure. But just try and draw it as accurately as you can. Don't just think, oh, it's going to go straight back up as soon as it hits the y-intercept. Try and just on your sketch have it roughly to scale. So we're done. Brilliant. We've sketched one with a 3x squared in. All right, I'm kind of sensing, I've done 2 examples. I've gone through some detail. Like, definitely try these now. Don't just like watch unless you're really confused still. Then because these are slightly different. Again, I'm going through 3, 4. slightly different examples. But if you want to watch on, you can. It's just I promote having a go at this point. Right, this next one is got a special name. It's in the form a squared minus b squared, because it's a square number minus another square number essentially, which you can factorize as a plus b, a minus b. That is something to learn. It's called the difference of two squares. Worth writing that down as well. Difference meaning you're going to subtract two squares because we've got two brackets being squared. That might not seem like it, but I can write this as 3x all squared. We've done stuff on this in indices when we've expanded the brackets. You can put it back in like this, minus 8 squared. And that means it's now in this form, and I can literally write 3x plus 8, 3x minus 8. Okay, and the more you do of these, the more you just you basically just root the 9 in your head and the 64 in your head, and you just write this straight down. Just realized I forgot about the y-intercept, so that's going to be minus 64, and the roots are going to be this x equals, but it's going to be minus 8 over 3 and 8 over 3, and that was actually really quick. Doesn't matter that there's a 9x squared there. This is a difference of two squares. We can do it super fast. Get the graph plotted like that. Minus 8 over 3, 8 over 3, 64. Okay, yeah, the y-axis and the x-axis are not the same scale. That's okay. And actually, in this case, the turning point is going to be exactly in between the two roots because they're equidistant from the origin. So it's going to come down and it's going to actually go through the graph axis like that. And we've got another smiley quadratic. Fourth one, sad quadratic. That's why this one's a bit different. Now we've already covered, oh, by the way, we get y-intercept, which is going to be 9. It's going to be this number by itself. Now I should probably actually, first of all, write it with the x. It's just good practice to write it with the x squared first. That's better. And now, like we did before, factorize out the whole minus. This just makes things so much easier, in my opinion. Okay, because we've turned it into the same problem as previous. We've just got to put a minus in on the left-hand side. Right, two numbers that multiply to give 4. It's either going to be, this is why this one's a bit trickier again, it's either going to be 4x and x, or it's going to be 2x and 2x. Now, you have to go through these and eliminate them. But sometimes you can think about it carefully. If I put 2x and 2x in here, then whatever numbers I put in here, I'm always going to get even numbers. Like if I put like a 1 and a 9 in, when I times through, I'm going to get 2x and I'm going to get 18x. There's no way I could get that minus 9x. So I actually know that I can eliminate that. It's not going to be 2x and 2x. Instead, it's going to have to be, these are little sneaky things that you can do to do it quicker. It's going to have to be 4x and x. And now we can either try 1 and 9. That's not going to work. Like you can you can use my method, or you can start just like trying to do it in your head. If I put the 9 there, it's going to be way too big. If I put the 1 there, there's no way I'll get it. I think it's going to have to be 3 and 3, because I can see now I'm going to get 12x and I'm going to get 3x, and that is going to work. I'm going to be able to get minus 9x. I just need to put the minus there and the plus there. That works. I get my roots, which are going to be minus 3 over 4. Let's just try that again. I should say, I've been a bit lazy. I should say x equals minus 3 over 4 or 3. And we're nearly there. I'm running out of room, but I can just about fit it in. So I know it goes through 9. Let's put that up here. I know it goes through minus 3 over 4. Let's put that here. And I know it goes through 3, so I'll move that over here. And because it's a sad quadratic, you can even see, like, a happy quadratic wouldn't even make any sense. It's going to have to come up like this, carry on, and then come back down. And there we have it. I was going to draw a smiley face, but no, it's a sad quadratic, so I'll put a sad face there. So 4 examples as such, showing different aspects. Here, take out a common factor. Here, you can take out a common factor. You've got to deal with the 3x squared, but it's not so bad. It can only be 3x and x, and then think about the different combinations. Here, special case, difference of 2 squares. The more you do of these, the quicker it is. They're actually really nice once you've got your head around them. And this one, don't forget about your negatives. In this case as well, we have 2 options that we could have had for the x's, so that's the, that makes it a little bit trickier, but we ruled one of them out. Of course, you could get ones with more than 2 options and so forth. You just got to be patient, at least with the method that I've covered, that I'm sticking to. It's a solid method, trust me. All right, I want you to try the rest yourselves. I'm gonna just talk through them briefly. I'm not gonna go through the steps for every single one. So pause the video, try each of them. I've also got this on a handout, so you can get all the questions and try them first if you like. So first one, we can see the y-intercept is minus 2. That's what it factorizes to. So if I'm sketching this, I can see that the intercept is going to be down here, and the roots are going to be minus a third and 2. Okay, I've just found it from that factorized form. Something like that. Next one, multiple options here. Turns out that it's actually that. Y-intercept of minus 3. Roots of 3 over 2. And minus a third. It's just about, yeah, it's going to still come down. Try that again. Go back up. Okay, seemingly slightly harder one, but don't forget. Sorry, I just have a go at them. Don't forget about there's a common factor of 2 actually, so then it becomes slightly nicer to factorize. Still not that nice, it's got to be said. Okay, we're getting into more challenging ones. It's got, yeah, but this is where you want to be. You want to be able to factorize these ones. So minus 6 is the y-intercept. We're going to get 3 over 2 again, and minus a quarter. So I'll put the minus a quarter in first, and then the 3 over 2. Doesn't matter that the axes are not the same scale. Yeah, that's good enough. You could argue that actually looks a bit wobbly there. I should try and make it nice and smooth. Remember, we're drawing parabolas here. That's better. And it's a happy parabola. Okay, I'm just looking at the x squared. Whereas this one, sad parabola. So first of all, I'm just going to start you off with this one, like if you're not sure. Write it as minus 42x squared plus 47x minus 10, and then you'll factorize out the minus. And this is a hard question, right? I should just say, to be honest, right, I'd focus on 5 and 6. These ones are probably beyond A level, but if you can, like, you wouldn't get asked it in A level probably, but if you can do them, then you can cope with the earlier ones. That's the main idea. but don't stress if you're finding this a bit tougher. There's a few combinations, aren't there? But if you tried like 42x squared and x, it's just not going to work. You're not going to get the 47. You could see that. Actually, it's 7x and 6x. Like, I don't mean to make this too difficult if you are struggling a bit. You've got to be, but I think it's good practice to be patient and try and get there, honestly. Okay, so we're going to get minus 10. We're going to get, oh, this is looking horrible. We're going to get 5 over 6 and 2 over 7. So it's going to look a bit like this. Okay, and it wouldn't have made sense to draw a happy quadratic. All right, so if you managed to get this one done and this one done, fair play. Your quadratics are in a good place. It's more typical in A level you'll get ones like this or like this. Of course, you might have a negative in there. So I'd say focus on ones like number 5, and the harder questions will be ones like number 6. I think these ones are then going a bit beyond that, but the principle is the same, so it's worth doing. If you're not feeling that confident about factorizing, then like I said, get some more practice in. It's just practice, practice, practice. I know I've not given lots of questions today, but you can find some more to try. I am going to give a couple of challenge questions for anyone who is feeling really confident about their factorizing. It's good to really push yourself, so I'm be surprised if you've seen ones like this before. Give these a go. I'm going to talk through them in a bit more detail. So, first one is a little bit like the last one from last lesson, but actually a bit trickier. You can actually factorize for x squared. This is something we'll look at some point. So it's either going to be 4x squared and x squared, or it's going to be 2x squared and 2x squared. I think I can rule out the 2x squared and 2x squared again because there's an odd number here. There's no way that would work otherwise. So I can even see it. I'm going to put a 4 here to give me 16, and I'm going to put a 1 here. Then I get my plus 4, but I need both of these to be negative, and I've factorized. And what I factorized to is 2 difference of 2 squares. So the first one becomes 2x plus 1, 2x minus 1. And the second one, x plus 2, x minus 2. And we have ourselves, this is a quartic, by the way. It's going to, again, like last lesson, look like this, probably. So we've got the y-intercept. We're at this point, we just know we got the y-intercept. We don't even need to write it down. So it's going to go through 2 and a half. Put them roughly in the right place. Then minus a half and minus 2. And then we're going to draw this W. In this case, it is going to be perfectly symmetrical. You don't always get that. And I should have labeled this as 4. So if you got that, amazing. If not, I hope it makes sense. This leads us to the grand finale. How do we plot reciprocal functions like this, which seems maybe impossible when you first look at it, but it's actually not quite as bad as you think. First of all, we can factorize the bottom. It's a difference of 2 squares. Now, how does that help? Well, it kind of helps because let's just look for a moment. Do you know what? I'm going to draw it on, I'm going to draw it on these axes. And then I think in a green color, I'm going to plot not the whole function, but x plus 1, x minus 1. It's going to go through minus 1, and it's going to go through 1. And I'm going to draw it dotted, I think. It's going to also have a y-intercept of minus 1. It's going to look a bit like this. Now, believe it or not, that actually tells us a lot about the reciprocal function. Here's how. If you do 1 over this function, then suddenly, where it goes through 0, we've got a big problem. And actually, the graphs are going to go to infinity. So I can draw in, and I'm going to do this in red, I think. I can draw in a couple of lines, actually, that you'll see this later on if you haven't already, they're called asymptotes. But basically the graph is not going to go through here, because instead the graph, right, when it's really small and positive, it's going to get 1 over a really small positive number is a really big number. It's going to jump up here. And then as the graph goes to infinity, the bottom goes to infinity as x gets big. Actually, it's going to be 1 over a really small number. It's going to go to 0. So it's going to look a bit like this. But it's not actually going to touch 0 ever. Pretty happy with that. It shouldn't touch the red line either, so I'm just going to get rid of that. The same will happen on the left hand side. It's going to go to 0 from here as that one goes to infinity, and it's going to go to infinity here as that one goes to 0. Okay, believe it or not, that is what that part of the function looks like. Now, if I look at the -1, 1 over -1 is still -1, so actually it's going to go through here again. This time as it approaches 0, it's actually approaching 0 from the negative direction. So 1 over a really small negative number is actually a really big negative number, and it's going to end up here. And likewise, this one's going to end up here. And this function, to finish off, is going to look like that. This is some pretty high level stuff we're doing here, but I hope the principle makes sense. You can actually plot the reciprocal of any function if you know the function itself. You know, you can just think about it. Think about when it goes to 0, when it goes to infinity. Yes, it's only a sketch, okay? But I've got this point exactly. That's pretty much the only one. I'm not interested in the rest of them. I can see, I could draw these lines. Actually, I could say what the lines are. They're going to be x equals 1 and x equals -1. Right, you will actually see things like this in A level. Maybe not for this kind of function, but later on you'll look at things like 1 over sine x and you'll be expected to draw them. So that definitely wasn't a waste of time for the A level, and hopefully it was quite interesting as well. So you might even want to go away and think about some reciprocals of some other functions and learn about them. Anyway, well done on your efforts.